Well, welcome to this quick introduction and summary of what I've been doing with soft circuits and e-textiles. I'm actually first was able to make something of this at the first Maker Faire on this coast because I'd been dabbling with some of these materials, and then Leah Beakley and Susie and some of the other early pioneers were running around saying, well, there's this neat material, surely we can do something, build some circuits with this. But all the materials in the early days were designed for something else. So, for example, this is actually sold as a wound dressing because it's a silver-plated fabric. So it's pure silver on, I think this one is nylon, yeah. And it's sold because silver kills germs. And it's also highly electrically conductive. That's what appeals to us building circuits. But it was all available only through industrial channels and specialty outlets. Now we're in a rather marvelous situation where it's turned around and there's enough people building interesting clothing, wearables, that the designers of these materials are actually looking at these markets and asking some of the people creating these things what they want. So let me give a quick summary of what we're talking about with e-textiles. So the big revolution, which is actually quite old, about 30 years old, was to be able to do something a little bit odd, which is to get metals to stick to plastics and fabrics and fibers. So this is nylon, which has been copper plated. Chemically, it's extremely hard, and there was a really important reason for electronic circuit boards for them to solve this problem. It took a while for people to find an application for getting the copper onto the nylon, and almost every laptop, iPod, every device has some piece of conductive fabric in it. Why? Because when you put two pieces of metal together in a case, you have to make sure there are no gaps and slits, just like on a microwave. You don't want the energy coming out of the microwave. You don't want the radio frequencies coming out of your computers. So they use conductors like this to patch all the little slits and areas around the connectors. So that's the first bit, that's conductivity. That lets us move information from one place to the other in the fabric or in the system. But why am I interested in this? We've had conductivity for hundreds of years. That's, wires do that for us. Why do I want a fabric like this? Well, the reason relates to the world we're in and why you're here, because everything you're made from, the floor we're on, this wood, the metal, it was all once a liquid or from the air. Solids are things we have around, and they will all end up being gases and liquids. The rock we're on was once a liquid. There's this moment of solidity, which is this sort of brief thing we control. And the problem with hard things, like your iPhones and so on, is somebody else decided how big it should be. And the answer to how big things should be when it comes to interaction is almost always larger than they want to make it. So, for example, so that's the size question, but the other question is, what about shapes? The easiest things to manufacture tend to be rectangles, which is why most of our devices, our laptops and so on, are rectangles with maybe in 50 years we've progressed to curve off the edges a bit. But with fabric, I can build something like this, which is floppy. I can hang it over my body, but this can do the same sensing that the iPhone can do. It's got a matrix of conductors, the white threads, and it can sense distance on multiple touches. And this is a prototype from a student of mine, Christy Matson, who's going to build a very large wall shape.